Objectives. Determine whether a number is a solution. Use the additional property of equality and multiplication property of equality and division property of equality to solve an equation.
Solving equations using property of equality. Logical evolution. First of all, we have to identify equations and inequalities. And then we will talk about solutions of equations. Next step, we have to learn how to get a solution and then how to check is it true or not, is it solution or not, and then how to show the answer.
Equations and inequalities. Symbol equal and two symbols of inequality. If we have two expressions and if they are equal, like this example, positive 1x and positive 1, one expression, and 3 is a second expression. If these two expressions are equal, and we can read this as a positive 1x and positive 1 is positive 3. Then we would call this an equation. If you have the same two expressions and for some reason left one is greater than right one, and we can read this as positive 1x and positive 1 is greater than positive 3, we would call this an inequality. Or it can be opposite situation, so right side is greater than left one, and we can read this as positive 1x and positive 1 is less than positive 3, then we would call this inequality. Linear equations in one variable. Example number 1 show a linear equation in one variable because you can see only one variable, x. Example number 2 represents linear equation in one variable. One variable is y. And for word linear, we have to make an assumption that exponent for variable is just 1. We usually don't show this exponent. And example number 3 represents linear equation in one variable because we can see only one variable, x, and exponent for x is invisible, it's just 1. On the right, you can see example for non-linear equations. Example number 4, exponent for variable is just 2, so it will be quadratic. Example number 5, you can see a square root of y, so it's not linear equation. Example number 6, x in the position of denominator, so exponent for x would not be 1, but we will talk about this in later courses. In example number 7, you can see absolute value bars, so it's not linear equation. And example number 8, you can see exponent for variable is 3, so it will be cubic equation, and you can see two variables, x and y. So this is cubic equation in two variables. In example number 1, I will use modeling for understanding the nature of equations. If we have two baskets, and if we put one apple in one basket and another into another one, we're adding one more apple to each basket and one more. Now these two baskets on the scale, and scale is in balance because we have 3 apples in one basket and exactly the same 3 apples in the second basket. Now let's replace 2 red apples by heavy object x to keep our baskets in balance. As a result, what we have on the left side, we have X and one apple, green one. On the right, we have 3 apples, and all the system is on balance. So now we have an equation. X and positive 1 is positive 3, or just 3. So here we have X and positive 1. This is our expression, and 3 is our expression, and these two expressions we combine using sign equal. This is what we would call an equation. And we replace 2 red apples by heavy object X. So now X is 2, and X is a solution. X is 2, X is a solution. To be sure that X equal to is a solution, we need to check. We can do this physically, replacing X by 2 red apples, and we can see the system is in balance. Or we can use algebra. We have to replace variable X by number 2 and check, is left side equal to right side? 2 and 1, is it equal to 3? Yes. So now we can say, yes, X equal to is a solution. The same equation, and now we will use algebraic approach without modeling. We are looking for positive 1x or for 1x. So we have to do whatever we can to get positive 1x on left side. How can we do this? If we add to both sides negative 1, which is opposite to positive 1, then we will have exactly what we are looking for, because positive 1 and negative 1 on the left gives you 0, and then positive 3 and negative 1 would be just 2. What we have to remember, whatever you do in order to solve an equation, you have to do this to both sides in order to keep balance. Now, algebraic checking. Again, we have to replace variable X by 2 and check, is it true or not? Is left side equal to right side? Yes. It's true. Then we can say, oh yes, X equal to is a solution. Or we can show this on real number line. You see, X equal to, or it can be curly parenthesis, X slash and then number 2. This 3 possible option to show the solution. The first, X equal to, second on real number line as a dot, and third option, curly parenthesis and number within curly parenthesis. Example number 2, require modeling. If we have piece of board and length is 10 feet. After that we cut this piece into 2 and the shorter length is 3 feet. Question would be, how long would be the longer piece? We don't know length, so let's mark unknown as a variable X. Now we can write out an equation. X and positive 3 is 10. And we are looking for positive 1x. We want to solve this equation. We want to find positive 1x. How can we do this? We can add negative 3 to both sides, and then positive 3 and negative 3 is just 0. What is left over on the left is just positive 1x, and right side would be positive 10 and negative 3 is 7. So solution is 7. X is 7. Now, the same example we will try to solve using algebraic approach. Positive 1x and positive 3 is 10. We are looking for positive 1x. So positive 1x is supposed to be on the left. How can we do this? We can add to both sides. In order to keep balance, we have to add to both sides opposite to positive 3, which is negative 3. And then we will have result positive 1x is 7, because positive 3 and negative 3 is 0, 10 and negative 3 is just 7. Now we can show our answer as 1x or just x is 7, or on real number line we can show as a point x equals 7. And now checking. Is it true or not that x equals 7? We have to replace x by 7 and check, is left side equal to right side? 7 and 3 is 10, so 10 equal to 10. Then we can say yes, x equals 7, and we can show the answer in curly parentheses. Example number 3. Positive 1x and negative 2 is positive 5. As always, we are looking for positive 1x. We have to add to both sides positive 2 because it's opposite to negative 2. And then result would be x is just 7, or x is positive 7. We can show our answer on real number line, or we can show it in curly parentheses. Example number 3. We have to solve an equation, positive 1x and negative 1 over 2 equals positive 5. We are looking for positive 1x. In order to solve, we have to add to both sides positive 1 over 2. And as a result, we will have x equal 5.5, and we can show answer as x equal 5.5, or we can show this as a point on the real number line. Modeling for another type of equations. Example number 4. If we have 150 apples, and those apples in 3 boxes, question is, how many apples do we have in each box? From this modeling, we can write out an equation. 3 times x is 150, and we are looking just for one positive x. Using our experience, we know that we have to divide it by 3, but we have to divide it both sides because we have to keep balance, and then 3 over 3 is 1, and 150 over 3 is just 50. So now we have x equal 50. Now we are going to solve the same equation using algebraic approach. What we have, 3 times x is 150, and we are looking for positive 1x. How can we get 1x? We have to divide it both sides by 3. Both, because we have to keep balance. Then we will have 1x is 50, because 3 divided by 3 is 1. 150 divided by 3 is 50. we can show the answer like 1x is 50 or x is 50, or we can show answer on real number line like point, and then checking. We want to be sure that x equal 50 is a solution. We have to replace x by number 50 and check, is left side equal to right side or not. 3 times 50 is 150, so yes, x equal 50 is a solution. Next example, negative 2 times x equal positive 6, and we are looking for positive 1x. How can we get positive 1x? We have to divide it both sides by negative 2, and we will have negative over negative will give us positive 2 over 2, 1. So positive 1x equal positive 6 divided by negative 2, just negative 3. As you see, in our original equation we have negative 2 times x. In order to solve this equation, to undo this multiplication, we have to divide it. So, division undo multiplication. Now we have our solution, and we can show the solution on the real number line, and then checking if x equal negative 3, would it be left side equal to right side or not. Let's replace x by negative 3, and then negative 2 times negative 3 would be positive 6. 6 equal to 6, yes, x equal negative 3 is a solution. Next example, positive 3 times x equals negative 6. We are looking for positive 1x. And in order to undo multiplication, we are going to divide it both sides by 3. Because we remember that division undoes multiplication. And we have to divide it both sides because we have to keep balance. As a result, we will have x equal negative 2, because negative 6 divided by positive 3 would be negative 2. And we can show our solution on a real number line. So, or we can show a solution in curly parentheses. Now checking if x is negative 2, would be left side equal to right side, we have to replace in our original equation x by negative 2 and check. 3 times negative 2, is it negative 6 or not? Yes, it is. So x is negative 2 is our solution. Next equation, x divided by 3 equals negative 1. We are looking for positive 1x. X divided by 3. In order to solve, we have to undo this division. How can we do this? We will multiply both sides by 3. Both sides because we have to keep balance. And then 3 divided by 3 is 1. We cancel 3's, and negative 1 times positive 3 will be negative 3. We can show this result on the real number line and checking if x is negative 3, would be left side equal to right side. We have to replace x by negative 3 and check, is it true or not? Negative 3 divided by positive 3 is negative 1. Yes, it's true. So we can say x equal negative 3 is a solution of our equation. You can show using curly parentheses, but we can show only negative 3 within curly parentheses, and it will be okay too. Next example. In our equation we have negative sign in front of fraction x over 3. And right side is just 0. In order to solve this equation, we will take similar actions which we used before. We will multiply by 3 both sides in order to get rid of denominator. So 3 divided by 3 is 1. As a result, we have negative 1x equal. But right side, 0 times 3 is still 0. Now we are looking for positive 1x, and we have negative 1x. In order to get positive 1, we have to divide it by negative 1 both sides, and then negative divided by negative on the left gives us positive 1x or just x, and 0 divided by negative 1 is 0 because 0 divided by any number results in 0. Now we can show a real number line solution of this equation, or we can show on solution set. Next example. 2 times x divided by 3 is negative 1. And we have to solve for positive 1x. We have to have 1. How can we get 1? On your right you can see 3 over 2 times 2 over 3 will be just 1. So we are going to multiply both sides to keep balance by 3 over 2, and now we can cancel. 3 over 3 is 1, 2 over 2 is 1, and we have 1x or just x equal negative 3 over 2. We can show a real number line, and then question is it true or not? You can check if you want. Try to do by yourself. Next equation. Negative 1 and 2/3 times x equals negative 1. In order to solve this equation, let's convert mixed number into improper fraction, and then we will work exactly as we would do with regular equations with fractions. So we will multiply both sides by negative 3 over 5 in order to have positive 1x, because we know negative times negative gives us positive. So you can simplify using cancellation, and result would be just 1x is 3 over 5 positive, and we can show a real number line. Summary. To solve an equation, we have to take actions in reverse. Addition of opposites undoes subtraction and addition. Division undoes multiplication, and multiplication undoes division. Just follow this rule. Algebraic approach in solving equations allow you a shortcut which can save your time, especially when you're on test or quiz. Let's look into left side. You can see standard equation and standard solution. Now I want you to look into green area, the same equation, and now if I am going to move negative 2 into opposite side, and when I am moving, negative 2 is becoming positive 2, and I will have immediately x equal 5 and positive 2x is 7. This is what you would call moving terms. when you are moving term from one side to another one, just need to change sign. Practically, you just need to show which term you are moving, and then you can show next line, and this term will be with opposite sign, and simplifying, and this is a solution. Next example. On green side, I copy this equation and look, if I want to move positive 2 from the left to the right, I just need to change sign. Positive 2 on left becoming negative 2 on the right, and then x would be just 5 and negative 2x is 3. This is a shortcut, the same answer, but we can get it faster. One more example, moving terms. In our equation, we want to move negative 6 from the left to the right because we want to isolate x. X is supposed to be by itself on the left, and then negative 6 becoming positive 6 on opposite side. Simplifying 5 and positive 6 is just 11. The same example, and this is practical approach. You are looking for 1x or positive 1x. This is why you have to move negative 6 from the left to the right, changing the sign. That's it. And then simplify. 5 and 6 is just 11. When we have a request, solve an equation, we are looking for positive 1x equal. This is why we have to move negative 6 from the left to the right in order to have positive 1x by itself on the left. And when we are moving term, we have to change sign. So negative 6 on the left becoming positive 6 on the right. And then just simplifying, negative 5 and positive 6 would be just 1. This is a solution. We want to separate terms with variable and keep them on the left, and constant terms, which are numbers, to keep them on the right. But if you want to move term from one side to another one, you just need to change sign. So negative 6 on the left becoming positive 6 on the right, and then we have to simplify. Negative 5 and positive 6, just positive 1. The same equation using algebraic approach. We're supposed to separate terms with variable and keep them on the left, and constant terms, numbers, on the right. For that purpose, we have to move positive 1x from the right to the left and negative 6 from left to the right. Don't forget to change signs. So then we will have negative 1x and positive 2x. We combine as like terms, and we will have positive 1x equals 6. This is a solution. The same equation, more clear presentation. We are trying to keep all terms with variables on the left and constant terms, numbers, on the right. So we have to move positive 1x from the left to the right. Positive 1x on the right becoming negative 1x on the left, and negative 6 on the left becoming positive 6 on the right. Now negative 1x and positive 2x, they are like terms. We can combine them it will be just 1x equals 6. We solve an equation. If we want to see our equation in more familiar presentation, we can move negative 9x from the right to the left and positive 18 from left to the right. And we will have positive 9x equals negative 18 divided by positive 9 both sides. We can solve an equation. Example number 7 is very helpful for your further classes because you will see requests. Write the equation in the form expression in x's equal to 0. They call this set equation to 0. That means that we have to keep all terms on the left side and right side supposed to be equal to 0. That means that we have to move negative 9x and positive 2x squared and negative 5 from the right to the left, changing their signs. That's it. And then it will be negative 2x squared and positive 10x and positive 15, because you can always combine like terms.